Hello, friends. First of all, good evening to everyone. And I would like to start with a wish of New Year. I wish everyone Happy New Year 2025. This is our very first webinar in the new year 2025, and this is our webinar number 37 in our series of webinars. Today, we are going to talk about very important topic. That topic is what next after SF6 free switch gear. When we say SF6 switch gear, SF6 sulfur hexafluoride gas is a highly potent greenhouse gas with a global warming potential 23,500 times higher than the CO2. While SF6 is widely used as a arc quenching medium and insulating medium in all electrical switchgears like my circuit breakers, GIS, transformers, and but it offers several environmental and safety concerns that necessitates its phase out. When I say phasing out of SF6, it is because of seven basic reasons. The very first reason in that category comes with the global warming potential. And if you talk about the environmental lifetime of that gas, that is 3,200 years. That means once it is released, it can contribute significantly to the global warming. Even a small leak or improper disposal can have a large environmental impact. Second reason is although all my equipments are hermetically sealed, still during the maintenance activity, some damage, accidental damage, or some aging effect, there is chances of leakage of that gas. And over time, the amount of SF6 released into atmosphere can increase if proper monitoring and maintenance are not in the place. Third reason in the that category, the difficulty in the recycling. It is chemically stable and non-toxic, but non-reactivity makes it challenging to break down and recycle. Unlike other gases, it can't easily be reclaimed or reused after being discharged, leading to waste and environmental harm. Fourth reason in that category comes to be the regulatory pressures and international agreement. International agreements like Kyoto Protocol and Paris agreements have put pressures on the countries and industry to reduce emission of green gases, greenhouse gases, and SF6 itself comes in that category. Fifth reason, very important, is health and a safety concern. I already told that SF6 is a non-toxic, but it can displace oxygen in the confined spaces, creating an suffocation risk, asphyxiation if there is not large enough space and large enough leakage in that enclosed area. Apart from that, the byproduct of this SF6 during very high arcing temperature is not good for the health. And second important reason is when alternative solutions like dry air, vacuum technologies, eco-friendly gas mixtures are available, why not to adopt that thing? Last but not the least, the public perception and the corporate responsibility. As a global awareness of climate change increases, there is a great pressure on corporate to adopt such sustainable practices. The need to phase out SF6 in electrical equipment is driven by growing recognition of its environmental dangers, regulatory pressures, and the availability of safer and more sustainable alternatives. To talk on that important topic, we have two very experienced authors with us, Mubarak Khan and Volkas Lucas. And it's time to talk about the presenter. I want to give a brief introduction about the Mubarak Khan first. He is a passionate electrical engineer, founder and CEO of Muhandis Industries, actively contributing to the sustainable development of the nation by bringing the world's best technologies to India. His focus area is electrical safety, condition monitoring, reliability, and sustainability. He is basically running a Muhatis Industries, who is the authorized partner of Active Electrotechnic in India. And he is also manufacturing the medical isolation panels for hospitals which is must as per the BAS NEC SP 30 2023. He is from the merchant navy background and served many reputed companies in top management positions before starting his entrepreneurial journey. And he has traveled to more than 36 countries worldwide and trained more than 25 engineers. Now, time to give a brief introduction about Volcas. Volcas is a product manager such active electrotechnic for switch gears and substation product portfolio and has experience in the medium voltage network, and he has contributed to for the training program for sharing his technical knowledge and industry experience. His work reflects a commitment to advancing electrical engineering practices, promoting environmentally friendly solutions. In this webinar, he will be sharing insight into sustainable practices in medium voltage network. Before I invite Mubarak Khan, I would like to say thanks to all the supporters, Excellence Enhancement Center, YAMP, all my mentors in the group, Igniting Power Engineers. Thanks to everyone. And with that, thanks, I would like to invite Mubarak Khan first to start his presentation.
Thank you very much. Thank you, Rajesh ji. I hope I'm clearly audible to everyone.
Yes, you are.
Yes. Okay. If there is any issue in I think my network is a little poor. I believe, I don't know. So if there is any interruption, just let me know. Okay. So before any delay, I will start my presentation. Okay. So I would request Gulab sir to allow me to present.
You are co-host. You
the
do it.
No, the other profile with only the photo, that one. I have joined with laptop also.
So you can go on more and then you will find a record option. Share option. Either you can see a green button as a share.
I have joined from two devices and the other device is on. It's not. So just allow the other device also.
So what's the name of other device?
Mubarak Khan.
Mubarak Khan. Okay. Okay, sir.
Okay. Now I can share.
Kindly check.
Yes. Now I'm able to.
Okay.
So is my screen visible to everyone?
Please go ahead.
Okay. 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 So thank you, Rajesh ji, for giving a nice introduction. And without any delay, I will start my presentation. The topic is impact of SF6 on our planet and what are we doing about it. So a brief introduction. Already Rajesh sir has given a very good introduction, but I will just give a brief. So generally, I am founder and CEO of Mohandes Industries, and Mohandes Industries is empowering India with the best global technologies. So we help foreign companies for introducing their best technologies in Indian market, and we help Indian customers by solving their problem with the best available technologies across the world. As of now, we are partners with a company named Active Electrotechnic Turkey. Okay. So coming to this, the date. Okay, so 2nd October. When you see this date, 2nd October, what comes in your mind? Generally, for Indians, it's Gandhi Jayanti, right? But there is something significant about 2nd October 2016. Anyone remembers what is 2nd October 2016? I hope, but because we are not allowed to unmute, so I'll keep this question here and I will proceed. Okay. So the problem. Many of our people are living in Delhi and then people living in Mumbai and other areas. You know, the pollution in Delhi is really very bad, and it is causing the lower life expectancy to the people. Correct. Apart from the Delhi, the districts like Gopalganj in Bihar and Jaunpur, are also having a really very bad health index, as you can see. In this particular map, as you see, the parts which are more densely blue, it is the most affected areas with the pollution, and the parts which are more yellow in color are the places which are less affected. Okay, so if you see in India, if you want to find a livable place, there are 2-3 specific locations like Leh, Ladakh, and Kerala. Otherwise, all over India, the pollution level is really very high, and it is causing at least up to 10 years of life to the people living there. It's not only about the death, it's the bad life which we live with the diseases, with the other issues which we face, the breathing problems, and also those are also really very bad. Okay, so the people are experiencing in different ways, like somebody gets sick, somebody is not able to travel, somebody has to relocate because of the pollution. So there are different ways in which the pollution affects the people. Okay, now coming to the global warming, definitely what we think that because of global warming, we will not be able to wear our coats. We'll have to increase the temperature of the air conditioner a little bit, right? That is not the big issue. The bigger issue is because of global warming, the glaciers are melting, which is increasing the sea level. Increasing the sea level means the sea will come into the cities, and it will reduce the livable space as of now. So if any such thing happens, Mumbai will be the first place, or Chennai, to go under the sea. So which is a very bad risk for us. So now coming to, I'm going to play a video, okay, which is relevant to this topic, and which is a very great move by the world leaders in this particular domain. Okay. Okay, so I'm going to play this video. So around, there was a Paris Agreement, right? And in Paris Agreement, all the countries, they came together. They come to a consensus that they are going to contribute towards the preventing the uh, global warming and preventing the pollution, right? I don't know why the audio is not getting shared, but anyway, but we can see the text here. So all the countries, they put up their ambitious targets. So the convention, what they did was they allowed the countries to give their contribution on what efforts they will make to reduce the global warming, okay, to help the environment. And every country had to contribute on its own depending on his own conditions. Okay, so in that, India was also a part of that agreement, and India gave a lot of points on which India will take efforts to reduce the global warming. Okay. Let the video play. So these are known as nationally determined targets and NDCs. It contains the targets, policies, and protective measures which can be taken to reduce the emission, to stop the climate impacts. They also contain information on either needs for or provision of these things. Okay, and different, like we need to induce finance, develop new technologies, increase the capacities, etc. So these NDCs were published over a period of time, and it was recorded in a particular register. Okay, so every 5 years they review and see how much we have achieved in that particular domain. So that was about the NDC. Now coming back to the presentation. Okay, so what now about India, what India is doing. Okay. So India had put up 4 different ways in which it is going to help in the uh, conserving the environment. So there were 4 main verticals of the nationally determined contribution by India. First was life. Okay. So general adaptation in the behavior of the people in terms of contribution. Second was by reducing the emission of CO2 as compared to GDP by 2030. So the targets made was 45%. It should be reduced before the system. And then the third target was adaptation of renewable energy, which we targeted to have 50% adaptation of renewable energy by 2030. Okay. And the fourth target, which we took, was to go for net zero by 2070. Now, what these things mean, that we will see in further slides. Lifestyle means the general lifestyle changes like rainwater harvesting, using and consuming less energy as much as possible. It's not only about the energy efficiency, even it also depends on the amount of processed items we use and we waste. Because when we discard one cloth, that also impacts the environment, because there was some amount of energy which was consumed in manufacturing of that cloth. And when we discard that cloth, that also impacts that particular energy is wasted. So there were a lot of points which were life cycle changes, changes for the people, which was mentioned, but that is not topic of the day. So we will proceed to the next one. Second was the emission targets. So emission targets was that we need to reduce the emission by 45% by 2030 from the 2005 level. Okay. How much we have achieved so far? So from 5 to 10, we achieved 12%. Then by 2014, we reached 21%. By 2016, we reached 24%. And now, as per the previous calculation in 2019, we already crossed 33. By 2030, we target to go at 45%. We are at a consistent increase, and the progress is good. So with this and the next point, now coming to this, the renewable energy target. So we targeted that by 2030, we will reach 50% of the energy will be renewable. Okay. Back in 2015, it was 30.96. With a consistent increase in the renewable energy addition, capacity addition, we are already at 46.79% by 2004-5, which is beyond our target. Actually, we targeted to 40% by 2025, but we have already reached 46. So that is a good progress. So with this point and the previous point, what point I want to make is that India is really very serious about the green initiatives. We are always hearing from the utilities that they want to adopt new technologies which are supporting the green initiative. Okay. Now, goal net zero. That is the third goal, fourth point, which is going to like the goal net zero by 2070. Correct. So there are 3 main goals: short-term goals, medium-term goals, and long-term goals. Okay. The short-term goals is like enhancing energy efficiency, land and soil management, using the adaptation of electric vehicles, creation of carbon sink. Now, creation of carbon sink is very important. That is a very important, right? That we can contribute. There are other ways in which we can contribute to the environment, which will give us additional carbon credits. Correct. So that's why it's important. Now, coming to the medium term, like use of green hydrogen, use of bioenergy, and increasing the forest cover and agroforestry. Correct. These are the medium term. Long term initiatives can be use of green hydrogen in heavy industry, heavy transport, very low emission aviation fuel. We will completely phase down the coal, etc. So these are the initiatives which India is planning, and we, as we are there in the industry, we have seen these things happening continuously in our experiences. Now, this was about the whole India. Now let's talk about the power sector, because power sector contributes to a major portion of the energy exchange right? We are already are generating 456 gigawatt of power, correct? That is our installed capacity. Now, contribution to pollution. So what is the contribution to pollution of different sectors? Okay. First, we will see the major portion of the pollution contributor is the energy sector. As you can see, it contributes to 76% of the total emissions, okay, which is 2374 metric ton of CO2 emissions, correct? Second is agriculture, and then we have the IPPU. Now, IPPU means the industries, okay? So these are the major contributors. So as we can see, power sector is the major contributor in the pollution. Now, SF6 use in Indian scenario. I am just coming directly to SF6. According to MMR Private Limited, it is a market research company. The India SF6 market will see impressive growth of the market size of 56.4 million US dollar in 2020 to 88.8 million US dollar in 2027 at a growth rate of 6.7%. As per Volzo's import data, India imported around 600 shipments from China, Taiwan, and US. And we are the largest importers of SF6 in the world. What this point indicates, on one side, we are going down on our carbon potential. And from one side, we are increasing our risk of like wasting all our efforts by getting into renewable and other initiatives, right? Because if we adopt so much SF6, then definitely this SF6 will again be counterintuitive, or it can be it can damage our initiatives further. So now there is a line which is mentioned in blur. I think we cannot read it properly. I think it is written according to the latest data from the World Bank. India emitted 5772 tons metric of CO2 equivalent to 2010, and NDC communication of UNFCCC reported just 1,950 tons of CO2 equivalent. I am not able to read properly, but what it is trying to say is that World Bank data says that we released a lot, but the Indian report says it is very less. I don't know if it is true, which one is true and which one is not, but this is what the report was there. Okay. Now coming to this particular slide, where as you can see, as sir has also mentioned in his presentation, that SF6 is having a global warming potential of 23,900, right, as compared to CO2. If we consider CO2 1, then SF6 has 23,900. As you see in this particular table, okay. So in this particular table, if you see SF6, impact of SF6 or release of SF6 is from industrial processes and product use, which is 0.004%. If you remember the slides, 2 slides back, if you remember 2 slides back, here I mentioned that the emission from energy sector is this, and this one, this industrial sector is IPPU. Out of the 8%, 0.04% is the SF6 impact. Okay. Here the important point is that if, as an electrical engineer being in the industry, we know energy sector is the biggest user of SF6, right? Now, as per the government, whatever declarations we have made, the impact of SF6 is only because of the industrial sector, and then too it is 0.004%. Where the point I want to make that we need to look into this figure more closely again. Can energy have no impact of SF6 emissions? I believe it is not possible. Definitely, energy sector was one of the contributors. It's just the thing that we have not yet analyzed it. We have not yet done our research properly, or maybe there is something missing here, so we need to look into it. Here, as you can see, there are the major contributors, 73% is CO2, and there are other gases and SF6 is just very, very low, which is coming because they have considered only the industrial sector, IPPU sector, not the energy sector here. Now, just giving a glimpse of the energy sector, because nowadays India is very active and they are made it mandatory for the governments to report, for the companies to report the SF6 consumption and use. So in 2023, NTPC reported 20,250 ton equivalent of emission from losses of SF6 from energy production. That is NTPC. Coming to Power Grid says they are one of the largest transmission utilities in the world, and in the sustainability report of 2021, they reported the installed SF6 gas of 25 lakh kilograms in 2021. The percentage leakage increased from 0.16 to 0.19 from 2020 to 21, which translates to, can somebody help me read this number? 1 crore, 18 lakhs, 50,089, right? Of CO2 equivalent. So this is emission. Power Grid is a power sector, energy sector company, and this is the contribution from the Power Grid. If we analyze this data from all the power sector companies, it will definitely give a significant share of SF6 emissions and its equivalent CO2 impact on the overall energy scenario. In the overall graph, this pie chart will have bigger share of this SF6 if we analyze it correctly. Okay. Now, I was just trying to set the stage about what is the climate impact and why SF6, what is the scenario in Indian context. Now, as we know, ये मेरा देश है, right? And in our country, we are a very fast growing country. We have the increasing GDP, but faster than GDP, the population density is increasing, the land cost is increasing, energy demand is increasing. All these three, they contribute to the need of a compact switchgear. So if we don't use SF6 in the switchgear to make it compact, then what we will use? I end my presentation on this question. Okay, we are facing huge challenges in the environment, and we need government to make right policies to create the impact.
Thank you, Mubarak ji. Thanks
And
a lot
then,
for a wonderful presentation.
Sir, I have 2 slides more. Hello.
Please continue.
Yes, sorry. Because that was end of the presentation. This is just the other slides. Okay. So if we require the government to intervene and make the right policies, we need to work on that. If we want to do extra investments in terms of just a minute, my internet is bad, I think. I am sharing again. Okay. So if we need to make additional investments in terms of doing these things, we must do that. Okay. Now, again, why do we need to do this? Right. So the reply is for them. Thank you very much.
Thank you, Mubarak ji, for a wonderful presentation. You have already set the stage for Vulcan to start his delivery. And now I would like to invite Vulcan sir. Please start your presentation, and we are eagerly waiting for your presentation because you are going to talk about what next after SF6 gas switchgear. Over to you, sir.
Thank you. I'm glad to be with you. Thank you for the participating to our webinar and for the invitation. Today we are gonna briefly give information about SF6 free solutions which are one of the most important part of the future trends. My name is Volkan Ulutaş, and I'm working as product manager at Active Elektrotechnik, and I'm responsible for medium voltage switchgears and substations products. You can visit our website and social media addresses to take more information to Active's valuable solutions. Firstly, I would like to give some information about Active locations and briefly Active information. We have 5 locations: headquarters in Istanbul in Turkey. Resistor groups, low voltage panels, medical solutions are manufacturing in Sakarya factory in Turkey. Medium voltage switchgears, substations are manufacturing in Turkey. We have an office in order to manage for whole process and full abroad sales activities in Germany. And our electronic products like SCR, GTEC, developing in R&D center in Bilişim Valley in Turkey. Our valuable solutions are developing day by day since 1981. I would like to give brief information about general products in Ankara factory. We have 3 main product groups as switchgears, fixed substations, and mobile substations. The switchgears are divided 2 main groups as gas-insulated and air-insulated switchgears. As Active Elektrotechnik, we are aiming to have more sustainable and greener solutions. So we developed the Aegis product. The Aegis product is manufacturing up to 36 kilovolt electrical values. And you can see the air-insulated switchgears in the right side of the switchgear section. SME switchgear is the metal enclosed switchgear and manufacturing up to 40.5 kilovolt. SNC 36 kilovolt, SMC series is 46 kilovolt. SNC double busbar series is the same features with the SNC and only extended to upside in order to having to double busbar structure. And in the substation groups, we have EHASUS, concrete substations, monoblock and prefabricated concrete substations. In the mobile substations, we are able to manufacture in the different combinations whatever customer needs and project specifications, like high voltage, medium voltage, medium voltage, medium voltage, and medium voltage, low voltage. Today's main subject is sustainability and greener solutions. So we will discuss Aegis product, which is not contain fluorinated gases. All type test processes completed in 2023. Now, I would like to indicate why we developed this product. As you know, SF6 is very strong greenhouse gas with 24,300 global warming potential. It means 1 kilogram SF6 gas is equal to 24,300 kilogram carbon dioxide emissions. We are facing the different values like 23,900 and 24,000, 25,000 global warming potential. This is the different reports from EU. This is the latest value published from the EU. So SF6 gas has an extremely long life time with 3,200 years. Actually, SF6 gas has quite good insulation levels, so it's commonly used in electrical equipment. However, it's very harmful to gas to nature and people. Normally, SF6 gas is not harmful to people, but in case of any arcing, people could be exposed to poison gas. So it's dangerous to people and nature. If you are using SF6 gas in your facility, you will have obligations of report of the F gases and special equipment to use, training people who operates the products, maintenance problems due to use and fill and unfill of the SF6 gas. For all harmful effects of SF6, countries are publishing their own restriction plans. The first important regulation from EU, 24 kilovolt and lower voltage level switchgears will be banned after 2026. Upper voltage levels of 24 kilovolts, like 36 kilovolt, will be banned after 2030 in EU. New York and California is the same situation as well, and Taiwan is the same situation. Saudi Arabia is studying their restriction plans, like NEOM projects. South Korea already published their restriction plans, and South American countries and southern the countries is studying their restriction plans. The dry air technology is using in the gas insulation medium, so global warming potential is equal to 0. According to IEC specifications, loss of service continuity LSC2, PM partitioning class, APLR internal lock classification, IP3X protection class. The Aegis product has the 24 and 36 kilovolt voltage levels. Feeder rated current is 1250 amps and 2000 amps. 2000 amps will be published in the first quarter of 2025. Main busbar rated current 1250, 2000, 2500 amps available for now. Rated short circuit withstand current 25 kiloamps and 31.5 kiloamps with 3 seconds. Aegis product is suitable for primary systems of the network, like power generation, transmission and distribution, renewable energy, nuclear, oil and gas, transportation. Dry air technology is used in gas insulation medium, so it's eco-friendly. Sensor integration could be possible in order to follow health of the switchgears like pressure, temperature, humidity, and suitable for industry 4.0. So it's technological. The dimensions are very small, and so it's compact. Minimum 30 years sealed pressure system to be supplied, and also you can reach cable compartment, busbar compartment, current transformers, voltage transformers whenever you need. So maintenance free. The most important using area is isolating from external factors. You can see the different combinations of the applications, and disconnector switch or the circuit breaker is located inside of the tank with pressure. The footprint is very small according to air insulated primary switch gears. The width is 650 millimeters. Solid insulated busbar insulation we have, and sealed pressure system, minimum 30 years lifespan we have, and front accessibility option to current transformer, voltage transformer, cable connection points, and busbar structure. Whenever you want, you can reach separately of them. And type tested production and easy installation to be supplied. We are active around the world, from South American countries to Indonesia, like everywhere actually, every countries we are active. And we are active in small smart buildings, transmission and distributions, healthcare facilities, transportation, renewable energy, industry, oil and gas sectors with different product groups. If you have any question in the future, you can touch to us by website or social media address. Thank you for joining to us, and thank you for attention.
Thank you very much, Volkan, for the wonderful presentation, insightful presentation. Now, before I invite some question, I have some basic question to ask. Can I ask some question?
Sure.
Yeah. You have talked about ages, and you mentioned in your slides that you are using dry air gases. Okay, can you describe it, what dry gases actually is?
The dry air gases, approximately 80% nitrogen and 20% oxygen mixing.
Okay.
The most important issue, humidity in the electrical connection points and switching points, especially in medium voltage and high voltage equipments. So the gases is natural gases, and we can imagine that the gas without humidity. That's why the global warming potential is equal to zero. I mean, we are using the dry air gas insulation.
Okay. Okay. My next question is, what happens when you are going to have new product in any utility? You must have all these product type tested. All your product, whatever you're talking about, are the type tested? If yes, can you confirm me the name of the IC which it is confirming to?
Definitely. Uh, we have the type tested in the accredited laboratories, IEC specifications, according to IEC specifications. As you know, the switchgear specification is IEC 62, 271, and 200. The switchgear is compliance with the IEC specifications. So now we are working on the new electrical features, and we will have the type test in the new electrical feature in the future. In the next, in the new soon, we have the type test 2000 amps for the feeder currents in the first quarter of the 2025. Currently for feeder 24 and 36 kilowatt voltage levels.
Okay, and another question, what I think, will you talk about that ages your product you are talking about? If I have to replace with the already existing SF6 system in my India, can it withstand, handle the same voltage and the capacity that SF6 gas has in India?
SF6 gas is
Yeah, can your dry air equipment handle the same voltage level that SF6 equipment is handling presently in India?
Definitely, the same electrical values and same dimensions and more practical and more sustainable products that we have. So I can say honestly, the same features with SF6 GIS and like dimensions and the other processes. And the advantages is sustainability and practical operations. So we can use easily everywhere.
Okay. And final question from my end. Then I will invite some question from audience also. Sanjay sir is also waiting for some question, and I'm going to hand over to him. But last question from my side. Can you provide me some examples of companies or projects you have already successfully completed with that product?
Hello, everyone. Can I answer this as a
Yes, yes,
salesperson?
please.
Hi, welcome to everyone again. My name is Ismail, and I'm a sales regional sales manager for India and some other countries as well. So yes, this is a very new product and new area for the energy sector. And we have successfully finished already for 2 projects. I could say one in Sweden metro project, and it's working very fine. We are gathering all the data until now, and we will share with you or in public in next coming days. And the other project was in Turkey, a private distribution company called Enerjisa. They are also going to take this product and place in their facility to test, because you see after 2026 up to 24 kV SF6 free is going to ban in Europe as discussed earlier. So companies has to be ready what they are going to use. Companies has already started to test what is available on the market. So we are located in very ahead of this topic. I could say that.
Okay, thank you very much. And now I am going to request Sanjay sir, kindly unmute yourself and raise your question. You have raised your hand, now you can ask your question. Gulab, unmute Sanjay sir. Yes, please.
Hello.
Anyone
Yeah,
has
my
any
name
question can raise the
my
hand. Yeah, please, sir. Welcome.
am I audible now?
Yes, welcome, sir.
Yeah, my name is Sanjay Agarwal. I am from CBS. My question is, a lot of substations have already huge quantity of contaminated SF6 stored in cylinders. How to get rid of this contaminated SF6 and how can it be made reusable? That is my question.
Oh, I believe Rajesh sir will be good person to answer that question.
Power grid PGCIL substations is one such customer. It has already been discussed. I was there in a meeting with the power grid. Every power grid substation has huge quantity of cylinder that has contaminated SF6. They do not have the solution as to how to make it reusable or how to get rid of it. Yeah, please.
Volgan, any idea about that thing?
The products will be revernalization, and we will face the new innovations. So for now, the busbar structure must the same values, like the dimensions needed to the same, and busbar connections is the same values. So if you have the substations with SF6 GIS, maybe we will adopt our products with adaptation switch gears.
See, I just wish to say it is not if it is a fact, it's a serious catastrophe likely to happen any day. Dr. Arora, I would also request you, since you are very active on conducting seminars and increasing awareness, this is something I call it something like a ticking bomb. You have already spoken how dangerous it is. Hundreds and thousands of liters of SF6 is already stored and nobody has a solution. Dry air could be one of the solutions that could be used in future in place of SF6. But what is to be done? The whole country or the whole world is unaware of it. There has to be found out. Some R&D efforts have to go, serious R&D efforts have to go behind it. Get rid of this already contaminated SF6 on every substations. You can find out the details, you can put a RTI, and this is not only in India, it is happening everywhere. And let me also tell you, Power Grid is definitely a very educated kind of a transmission company. There are some states where the awareness about the poisonousness of SF6 is not clear to the people, and uneducated or the untrained people also handle that SF6 contaminated gas. Any unskilled handling can lead to a big catastrophe in the country for this. So I will request some serious R&D efforts have to go behind finding a solution for this problem. Yeah, thanks.
Thank you, sir. Thank you. What I feel the moving away from SF6 help mitigates its contribution to climate change, reduce risk to health and safety, and it align with the global efforts to reduce green gases emission. But apart from that efforts we are talking about, we have to think about the recycling and reconditioning of the already contaminated gases already available in the utility. And your point is well taken, and we will try to address that thing in the next webinar to come.
Right,
Now,
sir. Thank
I
you.
would like to request Apao sir, he want to ask something respective, sir. Please unmute yourself.
I wouldn't. Good evening. Good evening, Rajesh ji. It's a very good session conducted by Mr. Mubarak as well as Solkan. They have delivered both perspectives. Mubarak delivered the actually the potential global warming potential 25,000 greater than the carbon emission, normal CO2. That type of potential emission it does that. And Olkan also submitted that they are already going for sustainable development in this switchgear production. Actually, we are addressing this specific area of switchgear, how much of SF6 gas is involved in it. Rightly, the previous person asked a correct way of approaching dealing with this. We are bothering about the leakages. As per Mubarak presentation, the leakages alone contribute to this much of CO2 emission. But what about the production? We are getting all that produced from China and US. But what will be the leakages occurring during production? And there are so many things available. We are dumping without using it. What will happen? Not only in India, in other countries, because of urbanization, every country is going for SF6. I don't think SF6 can be extended to, can be stopped at EHV. That is, for medium voltage, it is okay. We can abruptly stop, get a full stop for SF6. But will it happen to the extra high voltage installation? That we have to think of it. So, judicial growth as well as sustainable development means not only avoiding all the illicit things, but we have to sustain. We have to bear with some disturbances. In short, we can say there is no expiry date for the poison. Once expiry date is put, then poison is always a poison. We have to get it off. But is it possible? Is there any chance for the completely available? That means completely available SF6, which is lying in our hand. So, as you said, another session will be required to address these issues rather than this issue of rather than the energy management or power management, it's issue of CO2 emission reduction and global warming potential. Anyway, thank you, Mr. Rajesh. It's a good, innovative solution. Thank you.
Now I would like to invite PP Vaisa to say a few words about the session. Gulab, unmute Vaisa. Sir, you are on mute. Yes.
Hello.
Yes, sir.
Hello. Hello.
Yes, sir. Please continue.
Rajesh, are you getting my voice?
Yes, yes. Please continue, sir.
Oh, yes. See, at the outset, I must congratulate Rajesh ji. This is the 37th webinar. I think is a huge initiative. I must congratulate him for organizing. This is probably one of the best subjects we could attend. You say point of concern for everybody. I think all my friends who have attended this session must be feeling really happy to have together this knowledge on the problems created by SF6 and the alternatives. So, Mr. Mubarak Khan, he has done a wonderful job. I think he has made it quite lucid presentation. Everything was very clear. See, he talked about the national scenario. He talked about the global aspects, particularly while talking to Delhi. I personally feel that the stage has come already. The effect of global warming has started. We have started busting of ACs at Delhi at 53 degrees centigrade ambient. So a lot of worry for everyone, all of us. So all these areas we have to address very seriously. And not only that, the point of worry is that we are as Mr. Mubarak has told, is we are the largest importers, which is again a problem. See, we and the problem, once we are getting the largest import, we are having the maximum problems also. And exactly as Mr. Sanjay has told, you see the area of disposal of contaminated this SF6, I think is a problem which we have to sort out. Otherwise, you see, with the time passing, you see, we'll be in great trouble, I tell you. And the alternatives, Mr. Volkan, he has done quite well, told you the alternatives about dry air gas, use of dry air gas. But let us see how best we can utilize it, right? I think this is the infant stage. See, we have to see how we can use those alternatives, but we have to work hard. I think this is a very, very, very important area where we all have to focus in the days to come. I think Rajesh ji has to organize more conferences on this subject, because this subject is going to, if not attended, going to create a lot many problems in the days to come. So my best wishes to all of you, all the speakers, both Volkan and Mr. Mubarak Khan, and once again, my grateful thanks to Rajesh ji for doing a wonderful job, and my thanks to all the participants my friends, people listening me and listening all the speakers so well. Thank you so much. Thank you so much.
Now I would like to invite Davis sir, senior person on our group. And sir, please unmute and say a few words. And what you want to ask, you are free to ask.
Yeah. Thank you, Rajesh ji. Thank you, Wagi sab, Pav sab. Rajesh ji, thank you for arranging such a wonderful session on, particularly on alternate to SF6, because I happen to be one of the commission engineers. Started my career as a commission engineer, and maybe the first lot of SF6 breaker 66 kV was commissioned by me during my uh, working time. So that point of time, yes, of course, I was not aware of what was the risk handling this. And then if I admit you, I was not aware of anything of that. Awareness sessions were there not. So if it was released to atmosphere at leakage here and there, I think I need to be extremely worried now the way the presentation has been given. And Mr. Mubarak Khan has very clearly mentioned, I originally from Kerala, the safest place, but I happen to be living in Mumbai. So the global warming, you are giving me a very, very dangerous signal saying that I have to go back to Kerala now. So,
Take me also with you.
yeah, thank you. Acha, here my question come to, Mr. Volkan. In India, we have 1200 kV voltage levels at times, or 765 is very normal. I mean, we have it in many places. So it definitely comes as a EHV part. So do you have any solution for this at that level, or if you have today, up to what level voltage you are able to do this? And when you are doing this, what are the major challenges? Because SF6 is a undisputable insulation level it has. So to replace with the SF6, very easy to say. As a commissioning engineer, I know how an SF6 breaker works with if you compare with air circuit breakers. So what are the challenges and what are the maximum voltage you are able to offer this?
I think Ismail can answer that question. Ismail.
No, but I think it is not EHV. As far as I know, still there is a lot more to do. So I just want to get a more clarification. I understand Rajiv sir has already addressed it, but then that answer was not clarified properly, if I am right.
Yes. Let me answer this question, Mr. Drivers.
Yeah, please.
So up to now, we are having 36 kV product.
Okay.
But it's because the regulation and the requirement from the market, it drives us to create a product. At the moment, EU accepted F-gas ban regulation. So that's why EU countries is going to replace or is not, they are not going to buy any new SF6 free until 2026 up to 24 kV.
24 kV, okay.
24 kV. And by the 2030 year, and 36 kV is also going to be banned.
Okay.
But as of today, we are having the solution for 36 kV.
Okay.
Solution. Okay. And in the future, I think it will be widely spread to other higher voltage levels.
Okay. But then now, I mean, since you are into the market, you are into R&D and all, in EHV level, when can we expect this in 400 kV and above levels? I mean, I know it's a very difficult question. One cannot answer because research and development going on. Because I was a part of Siemens, so I have been associated with the SF6 breakers and challenges. So when I was in service, I could not even think of it. It can be replaced in EHV level, but then now today, because of the challenge, it is a requirement to replace. So when will it happen? If it all happen?
Frankly, I don't have any time with me at the moment. But it's again, if there is a inquiry from the market, from the sector, then companies can focus on such a solution. today we have the solution SF6 free, but companies are not welcome to buy because it's a new technology and it requires investment.
Right, very
It's
right.
expensive than a regular SF6 free, of course, because it's not widely used and it requires more pressure in the tank. For example, the pressure with the SF6 free, usually it's 0.5 bar or 0.8 bar maximum. But when it comes to dry air and the tank where you put this air is almost 2 bars.
Right,
So it requires a 6 millimeter steel sheet in order to protect this sealed system.
right,
And this 6 millimeter of this steel, of course, comes with a value.
right.
And companies needs to and tend to be in this way so that they can invest for this new technology, and then companies can offer. But as of today, it's not. Of course, we are saying it's an environmental product. We need to think global warming, but on the other side, without a regulation from the regulation makers, people or companies are not going to use widely. So that's why EU took a decision in this part, and then it will start. And I think after 2030, we will have high voltage level. So we have at least 5 or 6 years to have these voltage levels with us. And by
Thank
the
you.
26 years, we will have high voltage level, I guess.
Yeah, thank you, Ismail. Just to add one more point, why the vacuum technology is not getting replaced as a replacement for SF6?
Vacuum technology.
Yeah, vacuum breakers are widely used up to medium level. So SF6 breakers, which are up to the medium voltage level, why? I mean, are you also planning to come with a vacuum breakers?
I do not have information about this. We are not having any R&D at the
Okay.
time for
Okay.
the.
I want to make a clarification on this.
Yeah.
So this particular technology, what we are talking about, it's not about the interruption medium. Interruption medium, arc quenching medium, it remains SF6 or vacuum. Okay. The SF6 free, what we are talking about is the overall busbar insulation. Like we have in the GIS, we have the busbar insulation is SF6 medium. It is to reduce the size of the switchgear. The interruption medium will still remain vacuum or SF6 as it is required by different applications.
Now that means
I
you are
hope.
talking about GIS here now, gas insulated substation. I'm
Yes,
talking about a normal EHV 220 kV circuit breaker or a 33 kV outdoor circuit breaker or indoor circuit breaker where you don't need any bus bar insulation. It is only the breaker which comes with this. So instead of
So-
SF6, one can always go with a vacuum circuit breaker. I mean,
So-
technically, I just want to know what is anything more if you can add to that.
we are not working on this interruption medium technology. That
Okay,
is
okay,
SF6 or vacuum. That is a difference. We are
okay.
working on the product where we have the whole switchgear, which is insulated by dry air, means that 33 kV. Because if you use the ambient air, the size will be like this. So if you use SF6 or SF6 free GIS, the size will reduce because we are using the busbar chamber is filled with the dry air or SF6. That is where we are working. That
Okay.
segment, not the interruption segment.
Interruption part, you are not there. Okay, okay. That is one of the most challenging area, interruption area. Okay, thank you. Sorry, I think answer took and the question took a lot of time. Rajesh ji looking at me.
Yeah.
Yeah, thank you, thank you.
And with that, I would like to finish the webinar because we are also close the limit time, 6:11. We are running out of time. And definitely we will come out with new webinars on different topics of new interest. And with that, thank you everyone. Thanks a lot. Thank you once again.
Thank you.
Thank you very much. Thank you.
Glad to be with you.
Thank you very
for
much.
participants and invitations. Everything
Thank
is
you
good.
once again. Namaskar.